The moment the deal was signed, the balance quietly shifted. No press conference. No flashing headlines. No official announcement from Washington. Yet somewhere between closed-door meetings and encrypted contracts, China moved faster than the United States and secured what many are calling the most disruptive energy breakthrough of the decade, Maxwell's MSED technology. For years, Maxwell's energy concept lived in a strange space between disbelief and fascination. Critics dismissed it. Supporters whispered about it. Governments watched, but hesitated. And in that hesitation, China saw opportunity. Because while the U.S. debated feasibility, regulation, and political risk, China asked a different question. What if this works? That question alone changed everything. The MSED deal wasn't about a single device. It wasn't even about vehicles or generators. It was about control of a new energy pathway, one that could reshape transportation, manufacturing, logistics, and national power structures overnight. Sources close to the negotiations suggest China didn't demand public demonstrations or media validation. Instead, they focused on scalability, integration, and exclusivity. Quiet test environments. Controlled deployment. Long-term leverage. And this is where the U.S. began to fall behind. American institutions are built on transparency, peer review, and regulatory caution. Strengths, until speed becomes the deciding factor. Every committee meeting, every approval delay, every internal debate widened the gap. China, meanwhile, treated MSED like strategic infrastructure. Factories were prepared before public confirmation. Engineers were assigned before headlines formed. Supply chains aligned before skepticism faded. By the time questions started circulating online, groundwork had already been laid. What makes this even more striking is how invisible it all was. No viral videos. No dramatic unveilings. Just movement. Behind the scenes, analysts noticed subtle signals, sudden shifts in research funding, unusual energy patterns, transportation pilot programs appearing without explanation. To most observers, they looked unrelated. They weren't. They were echoes of the MSED deal taking shape. And while American observers debated whether Maxwell's breakthrough violated known physics, China treated physics as a problem to be tested, not argued. That philosophical difference may have decided the race before it even began. But the story doesn't stop with who signed first. Because the real impact of the MSED deal isn't about China winning or the U.S. losing. It's about what happens when a nation commits to a technology the world hasn't fully accepted yet. And as more details surface, it becomes clear that this wasn't just an energy agreement. It was a strategic pivot with global consequences. Because once a strategic pivot begins, it rarely stays contained. The structure of the MSED deal itself reveals how seriously China took this moment. Instead of a single purchase or licensing agreement, insiders describe a layered framework, research collaboration on the surface, infrastructure integration beneath it, and long-term deployment rights embedded quietly in the fine print. It wasn't about owning the invention outright, it was about owning the pathway from invention to dominance. That distinction matters. While U.S. agencies reportedly requested extended validation, third-party verification, and public demonstrations, China prioritized controlled environments. Proving grounds instead of press tours. Metrics instead of marketing. In private facilities, the focus was not on convincing the world, but on answering one internal question. Can this be made reliable at scale? And that's where momentum accelerated. Pilot programs began appearing in unexpected places, industrial parks, transport hubs, research corridors. Not labeled MSED. Not advertised. Just quietly operational. To an outsider, they looked like routine upgrades. To those watching closely, they looked like preparation. Meanwhile, Maxwell's role subtly evolved. Publicly, little changed. Interviews remained cautious. Statements stayed measured. But behind the scenes, the center of gravity shifted east. Engineers, material specialists, systems integrators, entire teams were now working in parallel, compressing development timelines that would normally take years. This is where the U.S. dilemma deepened. American systems are optimized for certainty, for reproducibility, for consensus. But MSED existed in a gray zone, promising enough to matter, unconventional enough to trigger institutional friction. Every unanswered question became a pause. Every pause became an opening. China didn't eliminate doubt. It absorbed it. Instead of asking whether the breakthrough fit existing models, planners asked how existing models could be adjusted around it. Energy grids reimagined. Transport systems reconsidered. Even manufacturing assumptions quietly revised. And once that kind of thinking begins, it doesn't reverse easily. What's especially telling is how global markets reacted without fully knowing why. Certain supply chains tightened. Rare materials shifted destinations. Logistics investments moved. None of it pointed directly to MSED, but all of it aligned with a future where energy constraints mattered less than energy control. That's the part most headlines miss. This wasn't about free energy or miracle devices or headlines meant to shock. It was about leverage. About what happens when one nation prepares for a world where traditional energy dependencies no longer dictate speed, reach, or resilience. And as whispers of the deal continue to circulate, more countries are beginning to ask uncomfortable questions, not about whether Maxwell's breakthrough is real, but about what it means if someone else masters it first. Because in energy revolutions, timing isn't everything.
It's the only thing.
That realization is spreading quietly through diplomatic channels, boardrooms, and defense think tanks. Not as panic, but as recalibration. Because when a potential energy paradigm shift appears, the question isn't whether it will arrive, but who will be ready when it does. What complicates matters further is the ambiguity built into the MSED narrative itself. The technology hasn't been framed as a replacement, at least not yet. Instead, it's being positioned as an augmentation, a way to reduce friction, to smooth peaks, to operate independently when legacy systems fail. That framing makes it easier to integrate without triggering immediate resistance. And it makes the move harder to counter. In Washington, responses reportedly split along familiar lines. Some saw MSED as another overhyped claim that would collapse under scrutiny. Others warned that dismissing it outright mirrored past mistakes, moments when early skepticism allowed competitors to surge ahead quietly. But without consensus, action stalled. China didn't wait for consensus. They tested, adjusted, iterated. In parallel. That parallelism is key. Multiple development tracks running simultaneously, materials, control systems, safety envelopes, manufacturing readiness, each feeding into the next. If one path slowed, another accelerated. Risk wasn't eliminated, it was distributed. And distribution changes outcomes. As months passed, the language around MSED subtly evolved in Chinese technical circles. Less emphasis on breakthrough, more on integration. Less spectacle, more process. That shift suggests confidence, not in headlines, but in infrastructure. Meanwhile, Maxwell's breakthrough began to appear in unexpected conversations elsewhere. Not as a named technology, but as an assumption. Energy independence baked into scenarios. Vehicles operating beyond range limits. Facilities designed without traditional power redundancy. Those assumptions don't emerge unless someone believes the constraint is about to loosen. And that's what makes the MSED deal so consequential. Even if the technology never reaches the scale some imagine, the belief that it might is already shaping decisions. Capital flows differently. Timelines compress. Strategies hedge. In that sense, China may have gained something even more valuable than the tech itself. Optionality. The option to move first. The option to scale quietly. The option to reveal results only when they're undeniable. For the United States, and for everyone else, the challenge now isn't catching up in public. It's deciding whether to pivot privately, whether to rebuild processes around speed rather than certainty, whether to accept that waiting for perfect proof can be more dangerous than acting on imperfect information. Because energy revolutions don't announce themselves on a schedule. They arrive when preparation meets opportunity. What remains mostly unseen is how quietly the rules are being rewritten beneath the surface. Not through press conferences or viral demonstrations, but through procurement memos, pilot programs, and classified feasibility studies. This is where real shifts begin, not loudly but methodically. Because if MSED proves even partially viable, it challenges one of the oldest assumptions in modern engineering, that energy must always be replenished from an external, controllable source. Remove that dependency even temporarily, and entire systems behave differently. Logistics chains shrink. Vulnerabilities move. Control redistributes. And China understands system-level thinking exceptionally well. Instead of asking, "Does this technology work perfectly?" the more strategic question becomes, where does it work well enough to matter? Border regions, remote infrastructure, military-adjacent logistics, disaster response. Places where reliability outweighs efficiency and autonomy outweighs optimization. Those are the testing grounds that don't make headlines. At the same time, the silence around Maxwell himself grows louder. Fewer public statements, fewer demonstrations, more references to partners rather than prototypes. That transition from inventor to node in a larger machine is often the most telling phase of any disruptive technology. It suggests that control has shifted. And once control shifts, timelines accelerate. Inside American innovation circles, a familiar dilemma begins to reappear. The frameworks designed to protect against false breakthroughs are the same ones that slow reaction to real ones. Peer review, regulatory caution, investor risk aversion. Each valuable on its own, but collectively heavy. China's model trades some of that caution for momentum. That doesn't guarantee success, but it guarantees movement. And movement, in emerging tech races, is often enough. What's fascinating is how the narrative may eventually flip. If MSED matures under Chinese stewardship, the story won't be about how China outpaced the US. It will be reframed as inevitability, as if the outcome was obvious all along. As if no other path was possible. That's how history edits itself. But right now, the outcome isn't locked. The technology is still evolving. The alliances are still flexible. The data is still incomplete. Which means this moment, this quiet window, is where decisions still matter. Because once results surface publicly, it will already be too late to debate intent. At that point, the only question left will be who prepared early enough and who mistook silence for stagnation. Now is less a race and more a divergence. Two philosophies moving apart. One side prioritizing verification before commitment. The other committing early, then refining in motion. Neither approach is inherently wrong, but only one rewards uncertainty with leverage. And leverage is what the MSED deal quietly provides. Because even if the core technology evolves beyond its original form, the surrounding ecosystem, manufacturing lines, trained engineers, regulatory carve-outs, supply agreements, locks an advantage. By the time outsiders see a finished product, the real work has already been done. This is why the conversation has shifted away from "is it real?" toward "what happens if it is?" That second question changes everything. It forces planners to model futures they would otherwise dismiss. It forces competitors to hedge. It forces allies to choose sides without being asked to choose. And those choices compound. Behind closed doors, discussions are no longer about Maxwell alone. They're about replication. About whether the principles hinted at by MSED could be adapted, modified, or reverse-engineered into parallel systems. Not identical, but sufficient. Enough to close gaps. Enough to prevent dependency. But replication takes time. And time favors the early mover. What's especially telling is how little of this conversation has reached the public. That's not an accident. Premature exposure creates pressure to explain, to defend, to promise. And promises are liabilities when a technology is still fluid. So instead, there is patience. Patience in testing environments shielded from scrutiny. Patience in gradual scaling rather than dramatic rollout. Patience in letting others argue while groundwork is laid. And as that groundwork deepens, the strategic center of gravity shifts, almost imperceptibly. Energy discussions start including new variables. Defense planning scenarios quietly update assumptions. Infrastructure models gain new branches that didn't exist before. None of this confirms a revolution, but all of it prepares for one. Which is why the real significance of how China outpaced the US may not be revealed in a single announcement or breakthrough moment, but in a series of subtle consequences that only make sense in hindsight, once the world realizes the balance changed long before anyone agreed on why. And that realization, when it finally arrives, rarely comes with a dramatic reveal. It comes as confusion. As analysts notice that certain capabilities now exist where none should have been possible. As competitors discover that familiar bottlenecks no longer slow the same players. As strategic assumptions quietly stop working. By then, explanations won't matter. Because revolutions in energy are never just about power, they're about freedom of action. The freedom to operate longer, to reach farther, to function independently of fragile supply lines. And once one actor gains even a partial version of that freedom, every comparison changes. This is where the MSED deal becomes more than a technology story. It becomes a timing story. China didn't need absolute certainty. It needed a credible signal and the willingness to build around that signal before others did. That willingness turned ambiguity into advantage. While skeptics waited for clarity, infrastructure was forming. While debates continued, talent was being absorbed. While proof was demanded, preparation was underway. And preparation compounds. What's especially striking is how adaptable this strategy is. Even if Maxwell's original concept evolves, fragments of it, methods, materials, control logic, can seed multiple parallel innovations. Each one less revolutionary on its own, but together transformative. A mosaic rather than a miracle. That's the part often misunderstood. Disruption doesn't have to arrive as a single, world-changing device. It can arrive as 1,000 small changes that make the old system feel suddenly inefficient, outdated, unnecessary. And by the time anyone notices, the incentive to switch is already overwhelming. Meanwhile, the United States faces a familiar crossroads. Double down on skepticism and risk being late, or engage cautiously and risk legitimizing something unproven. It's a difficult balance. One shaped by history, regulation, and hard-earned lessons. But history also shows this. The cost of being wrong is visible. The cost of being late is often invisible, until it's irreversible. And so the story continues in quiet rooms, across spreadsheets and simulations, inside test facilities far from cameras. No countdowns. No declarations. Just motion. Because the true question was never whether China beat the US to Maxwell's breakthrough. It's whether the world will recognize the shift while there's still time to respond, or only after the rules have already changed, and that is where this chapter finally closes. Not with a launch event or a headline-grabbing demonstration, but with a pause. A pause where the world is forced to look backward to understand how the future quietly slipped ahead. The MSED deal may one day be remembered as a footnote, or as the spark that redefined energy itself. History will decide that part. What is already clear is this. Moments of transformation rarely announce themselves. They hide inside uncertainty. They advance while others argue. They reward those willing to move before the picture is complete. China moved. The United States hesitated. And Maxwell's breakthrough, whatever its final form, became less about invention and more about who understood timing better. Because in the end, the greatest advantage was never the technology alone. It was the decision to act when everyone else was still asking if they should. And by the time the answers arrive, the outcome may already be written.